So guys, I was talking about enthalpy in some videos and I'm sorry I haven't introduced it properly. It is now time to introduce it formally, and I love it because it's nothing complicated on the explanation, but understanding it and how to apply it, I think it might confuse you a little bit. Essentially, it's a mathematical value, H equals internal energy plus PV value. And probably you're wondering what is this PV value, and we have it a lot on open systems. Let's say that you could calculate enthalpy of many open systems if you had the internal energy and the PV value, which is essentially, for example, I like to call it, you have this open system, the push energy, you have volume, yes, you have pressure, yes. So you have a flow energy here and a flow energy going out. And even though you're heating here, you know that this stuff is moving. So who's doing that work? That work comes from the PV value, or at least I like to call it like that. So I get an idea. So I got internal value, which is totally dependent on temperature, and the PV value, which is dependent on other, let's say, other things. Actually, if I were to tell you, no, enthalpy, the letter H, has no value at all, has no physical value, but it's a very important abstract concept that will help us to model open systems in general, and even closed systems will help us as well. But essentially, we have enthalpy for open systems. So you can say that enthalpy is more or less the equivalent to internal energy. This is for open systems, and this is for closed systems. In general, guys, please don't make the generalization, but it will help you to understand more or less why do we need this value here. Now, why are we speaking about enthalpy? Because we're going to find it a lot in tables and diagrams. Actually, I told you pressure enthalpy diagram. And what's enthalpy? Essentially, enthalpy is energy. Many times heat energy, many times work energy. Enthalpy can be, let's say, calculated with either heat, work, or even kinetic energy, even potential energy can be transferred or exchanged to form enthalpy. So for now, just know that it is a very important variable. We will see it and study a lot in the first law, actually, well, a little bit when we're concluding on this section, but the first law is, I think, the most easy to get, and we will, of course, use a lot of exercises and you will get the idea. Enthalpy, I wanted to tell you that is extensive value, that is, that this depends on the amount of mass, of course. You have more mass, you will have more energy, makes sense. And enthalpy, very important, is a state function. It does not depend on the path. So if you have, I don't know, if you increase this ball, this height, well, you will have an energy. If you decrease this, you will not have that energy, of course. So it's like internal energy is similar, very similar. You can compare them, and yeah, essentially it's everything I wanted to show you. One last thing is, when calculating absolute enthalpies, this is very hard. Don't do it. We're more interested in the changes or deltas. Probably if I tell you, okay, this particle is moving, vibrating at 0 Celsius. Well, why would I, if I'm only interested in changing this particle from this state to 5 Celsius, why will I want to calculate how much enthalpy is needed to move it? Why not use the reference? I have this 0 Celsius, will be now my 0 enthalpy, and I can actually measure this change. Yes, I can. And when I get to 5, I will get a final enthalpy, which is, I don't know, maybe 10 joules, and I will get the difference value, the change value, which is enough because many times we will get heat as a change of enthalpy or work as a change on enthalpy. And even though you cannot calculate H2 absolutely or H1 absolutely, you can calculate the difference. So essentially that's what I wanted to tell you on enthalpy, guys. What's up, guys? It's me, chemical engineering guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos or if I should be changing something or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. So thank you guys for the support and the love.